Good morning, students. So today I would like to discuss a few more problems based on Newton's advancing difference method. See, I have shown you one problem here, example number 8, which has been already solved in the previous video. Just look at this once again. We shall repeat it, and then later few more problems I am going to show you, display it, and then I will be explaining orally. Now see, below are given the wages earned by workers per week in a certain factory. Below are given the wages earned by workers per week in a certain factory. Calculate the number of workers earning more than rupees 650 per week. So this is the question asked. Now look at the table. Weekly wages up to rupees 500, up to rupees 600, up to 700, up to 800, up to 900, up to rupees 1000. So what do you mean by up to less than? Remember, so less than 500, less than 600, less than 700, less than 800, less than 900 and less than 1000. Question, if you observe, it is asked to calculate the number of workers earning more than rupees 650 per week. More than rupees 650 per week. So underline that, more than. But the question is asked less than, right? So because question is given less than, but problem is to be calculated more than. Remember, up to 500 to up to 1000, that means less than 500, less than 600 and so on, less than 1000. Generally it is a open end kind of class interval, right? Less than kind, right? Interval may not be there. In such cases, less than, when you have observed in the class interval place, obviously the frequencies must be in LCF, less than cumulative frequencies. Less than cumulative frequencies means kind of increasing set of observations, increasing order you can observe in LCF, less than cumulative frequencies. Look at here, wages are given less than 500 up to less than 1000, and number of workers also exactly given in terms of LCF. It has to be given in terms of LCFs only, right? 50, 150, 300, 500, 700, 800. So LCF, it's an order. Generally in the LCF, the last term will be the total. Remember always, the last cumulative frequency value for up to 1800 would be the total. Remember. Now, Newton's method will be applied to a certain number of workers earning more than rupees 650. We have to calculate more than rupees 650. But the question is asked, question is given about all less than only. First and foremost, what we need to calculate? First we will calculate up to 650, and then later on we can calculate more than 650. Because from the total up to 650, as per the question, if you calculate up to 650, then removing that from the total, remaining all more than 50 only, no? For this, I have given you many times one example. If 10 benches were there in a class, from second bench to last bench when you need, then instead of taking from second to last, just removing the first one is more than enough. Then only these will retain, right? So that way, here also more than 650 it is asked. Up to 650 if you remove, remaining all more than 650 you will be getting it, right? So since 6 values of y are known, just look at here values 50, 150, 300, 500, 700, 800. Totally 6 values are there. Therefore, since 6 values of y are known, the leading difference table until 5th leading table we have to follow. What is the leading difference table? Look at here now. Weekly wages up to 500, up to 600, up to 700, up to 800, up to 900. Weekly wages are taken. And then number of workers, they are nothing but less than cumulative frequencies, because question is given in LCFs and even the frequencies are given in LCF mode. Now leading differences. Leading differences means you know y1 minus y0, y2 minus y1, y3 minus y2, y4 minus y3 and y5 minus y4. This way the leading difference has to be calculated first. Clear guys? Now delta 1, 150 minus 550, 100, 300 minus 150, 150, 500 minus 300, 200, 700 minus 500, 200. 800 minus 700, 100. That is the first leading difference, delta 1 can be denoted. And second leading difference, once again the second leading difference will be delta 1 1 minus delta not 1, that is nothing but 150 minus 100, 200 minus 150, 200 minus 200, 100 minus 200. So this way the second leading difference is 50, 50, 0 and minus 100. Again the third leading difference, keep on subtracting from down to top. 50 to 50, 0, 0 to 50, minus 50, minus 100, minus 0, minus 100. Again fourth leading difference, minus 50, minus 0, minus 50, minus 100, minus of minus 50 becomes plus 50. So minus 100 plus 50 will be minus 50. And then the last leading difference, delta 5, 50 minus 50 minus of minus 50 becomes plus 50. Therefore minus 50 plus 50, 0. Now the number of workers, they are nothing but the y0, y1, y2, y3, y4 and y5. So as you know that always we need to consider the first initial term at origin, x at origin, y at origin, and then first leading difference origin, second leading difference origin, and third leading difference origin, and fourth leading difference origin, and fifth leading difference origin value. And then what is x? The value of x to be interpolated. What is the value of x to be interpolated? More than rupees 650 it is asked. But first initially we are calculating just up to 650 only. That's why first 650 you take it. Minus, question what it is to be asked, that has to be taken. The value of x to be interpolated, 650. Minus, the value of x at origin. Value of x at origin is 500 here, right? So 500 you substitute here. 650 minus 500 divided by, what is the common difference between the observations? Look at here, the common difference is 500 to 600, 100, 100, 100, 100. So the common difference must be 100, right? The difference between two adjoining values of x. 650 minus 500 by 100, that equals to 1.5. So x value we calculated 1.5. Then look at this formula, Newton's advancing difference formula. Up to fifth leading difference we took. So up to fifth leading difference, the Newton's formula has to be written. Y0 plus delta naught 1 into x plus delta naught 2 into x, x minus 1 by 2 factorial, plus delta naught 3 into x, x minus 1, x minus 2 by 3 factorial, plus delta naught 4 into x, x minus 1, x minus 2, x minus 3 by 4 factorial, plus delta naught 5 into x, x minus 1, x minus 2, x minus 3, x minus 4 divided by 5 factorial. Now from this leading difference table, always the first observation, see here, 500 already we took to calculate x, 50, 100, 50, 0, minus 50, 0. All these origin values of leading difference along with the y, we have to take it. Substitute here. So y0 will be 50 plus delta naught 1, first leading difference will be 100 at origin, and then 1.5 x, what we calculated here, x, this has to be substituted, 1.5 into 100 plus 1.5 into x minus 1 becomes 0.5, directly it is written, divided by 2 factorial is nothing but 2 into delta naught 2 is nothing but 50 plus again 1.5 into 0.5 into minus 0.5, just substituted in place of x 1.5, and 3 factorial will become 3 into 2 into 1, nothing but 6. So anyhow this delta 3, the leading difference table only at origin is 0. That's why whole multiplied by 0 becomes 0. So delta 3 directly 0 can be written, and delta 5 also directly can be written 0. See here, after substituting 50 plus, simplifying 150 plus 1.5 into 0.5 by 2 into 50, you will be getting 18.75 plus 1.5 into anything multiplied by 0 is nothing but whole 0, minus 1.5 into 0.5 into minus here, minus 0.5 into minus 1.5, one value will be getting into minus 150 means minus value only will be getting, minus 1.1718. After simplifying this, you will be getting the answer 21758. That is why up to 650 it is. Clear? Up to 650 the value of y. But as per the question, what we need to calculate? More than 650 we want. Right? So from the total, 800. So 800 is the total number of persons. Remember, total number of workers. 800 people are there. Right? Because in the LCF the last value will become obviously the total. So the total number of workers were 800. Now from this 800 up to 650 wages, I mean less than 650, how many workers are collecting less than 650 rupees wages? 218, what we calculated. But as per the question, we need to calculate more than 650. So up to 650, 218 means out of 800, the remaining, if you remove 218 from 800, the remaining all are more than 650 rupees only, no, who are earning wages. So directly can be subtracted from the 800 total number of workers who are earning less than 650, 218, what we calculated. If you remove 582 workers were earning more than rupees 650. This is the question. Are you guys clear how I have subtracted and why I have subtracted there? Right? Because question, the data is given in terms of less than as well as less than cumulative frequencies. Directly we have to calculate less than type only. That's the reason less than 650 we calculated first. Later on, from the total, as per the question, we need more than 650. Less than 650, if you all remove them, those number of workers, remaining workers will become more than 650 ages who are earning, right? So that is what I have done. Are you guys clear? So this is the problem. Next, coming to the next problem, look at here. Example number 9. From the following table, find out the number of workers earning wages below rupees 25,000 or rupees 2500. So I mean 2500. Are you getting it? The number of, we have to find out the number of workers earning wages below rupees 2500. Clear guys? Now below, nothing but less than, under. Now look at the wages. 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. Clear cut class interval is given. But the question is asked about below. Class intervals are given, normal class intervals, exact class intervals, having both upper and lower limits. And the number of workers are also given, 50, 80, 100, 75, 40 and 25. They are also normal frequencies. In the previous problem, less than kind is given, class interval, that is the reason frequencies must be of LCF, less than cumulative frequencies. But here, clear cut class interval is given and normal frequencies are given. Just look at there is not an order it is. If it is an order also, because of the class interval, they are normal only. 10, 20 means that's a normal class interval, even though if the number of workers seems to be in an increasing order, but it doesn't mean that they are LCFs. If when we call them as LCFs, if the class intervals are given in terms of less than, below, under, up to, like that, then only we have to decide the number of workers. If it is in order, they are LCFs. But here wages are given normal frequencies, then obviously the number of workers are also normal frequencies only. Now as per the question, what it is asked, below rupees 25 wages, then this class interval 10, 20, 20, 30 can be converted to less than frequency table or no? Convert it now. Convert the data into less than frequency table and then find the difference table. How many known values are there? Here also there are 6 known values. Then obviously you will be getting up to 5th leading difference table. Look at here. This is the leading difference table. I have converted 10, 20, 20, 30, 30, 40. I have converted to below 20, below 30, below 40, below 50, below 60 and below 70. I have converted. And then number of workers. When we converted into LCF's kind, less than frequency table kind, obviously the frequencies must be in less than cumulative frequencies. Just as per the given data, go on converting to LCFs. First observation 50, second observation 50 plus 80. Okay, then third observation, fourth observation, just go on adding it. Same, this table 50, first one, 50 plus 80, 130. Next 130 plus 100, 230, 230 plus 75, 305, 305 plus 45, 345, 345 plus 25, 370. So this way the leading difference table LCFs we have converted, because the data also normal class intervals we converted to below, and these are also must be in LCF, less than cumulative frequency table. These two columns, less than cumulative frequency tables, these two. As per the question below it is asked, that's why we converted in terms of LCF table. Now leading difference 130 minus 50, 80, 230 minus 130, 100, 305 minus 230, 75, 345 minus 305, 40, 370 minus 345, 25. And then one more, the second leading difference 100 minus 80, 20, 75 minus 100 minus 25, 40 minus 75 minus 35, 25 minus 40 minus 15. And this delta 3 again leading difference minus 25 minus 20, that means minus 45. Here minus 35 minus of minus 25, so plus 25 it will become, that's why minus 35 plus 25 is minus 10. And then minus 15 minus of minus 35 plus 35, so minus 15 plus 35 is plus 20. Again the fourth leading difference minus 10 minus of minus 45 plus 45, therefore minus 10 plus 45 is 35. 20 minus of minus 10 is plus 10, so 20 plus 10 is 30. So 30 minus of 35 is minus 5. This is the leading difference table, and always we put it in box. This is x naught, this is y naught, this is delta naught 1, delta naught 2, delta naught 3, delta naught 4, delta naught 5. Since the value to be estimated is not in the class limits of the data, apply Newton's method to estimate the number of workers. This is the formula. The value x to be interpolated. What is to be calculated? Who are earning below rupees 25. That means 25 will be the value to be interpolated minus the value of x at origin. What is the value of x at origin? 20. And then divided by, what is the common difference? 10. So 25 minus 20 by 10 is 0.5. Now up to fifth leading difference, that formula has to be written. Y naught plus x into delta naught 1 plus x minus 1 by 2 factorial into delta naught 3 plus x minus 1 x minus 2 by 3 factorial into delta naught 4, x minus 1 x minus 2 x minus 3 x minus 4 by 5 factorial into delta naught 5. Substitute all by simplifying, you will be getting the value 83.1835. This is y below 2500 wages. How many workers are earning? Approximately 83 workers. They are earning below rupees 2500 wages. So here we need not subtract anything, because in the previous problem the question is given more than, but the data is given in terms of less than cumulative table. That is the reason the final total has been subtracted from the overall total to get more than value. But here clear cut question, straight question is asked about below. Data is given in normal class intervals and normal frequencies, that has been converted to less than cumulative frequency table, and then we substituted here. Directly we got below 25. No, as per the question we converted, but the previous problem as per the question we haven't convert. Right, if you want to convert in the previous problem, what has to be converted now? There the given up to has to be written in terms of more than, and cumulative frequencies what they have given in terms of LCFs, convert to frequencies and then frequencies to MCFs. So it's a time taking laborious process. That is the reason from the total there is a possibility to subtract. Directly we have done in the previous problem, but here that kind of situation scenario is not there. Straight away we can do it. Clear guys? So these are the separate kind of model problems. Clear? So now I will show you few more problems like this from the exercise. Just look at there. So here exercise questions from here 16. Use Newton's method to find number of employees where the wages were. Straight question, there is no below, above, more than, less than, like that. Directly it can be calculated. Even here also x equals to 25, this is also directly can be calculated. Now here this is also direct question, A is 26 directly. Now 19th question, you look at there. This is the question now. interpolate the number of persons below the age below 70 years age. So below we have to calculate, obviously the data has to be converted to less than cumulative frequencies table. Now ages, straight away class intervals are given, and frequencies, individual frequencies, these are independent frequencies, they are not in kind of MCF nor in LCF. But this problem seems to be an MCF kind of model. But do you think that they are MCFs? Absolutely not. They are not MCFs. Remember, okay, because here class intervals are not given in MCF kind. Then obviously these frequencies will not become MCFs. Here normal class intervals are given. Obviously these 333 persons are there between 0 to 20. That is not even total nor more than frequencies. Clear? So now as per the question below, now convert this below 20, below 40, below 60, below 80, below 100, and these converted to LCFs. First value 333, next value 333 plus 160, how much? 493, and then next value 493 plus 135, 593, 598, and then 30, 628, 628 plus 67, how much? 628 plus 67, 695, 695 plus 65, 760, right? So and then find out the leading difference. Here find known values up to fourth leading difference you will be getting. Take all the initial values. X 70 minus 20 divided by 20 class width, you will be getting X, the value which is to be interpolated, 70, minus the value at origin, this has been converted to less than 20, that means 20, 70 minus 20, 50, divided by width is 20, so 50 by 20 is 2.5, that will be X. Up to fourth leading difference you calculate, Y equals to Y naught plus X into delta, X into delta naught 1 plus x minus 1 by 2 factorial into delta naught 2 plus x minus 1 x minus 2 by 3 factorial into delta naught 3 plus x minus 1 x minus 2 x minus 3 by 4 factorial into delta naught 4. Substitute all the origin values of y naught, delta naught 1, delta naught 2, delta naught 3, delta naught 4 after converting this to less than cumulative frequency table, because the question is asked for below less than kind. So data, the table has to be converted to less than kind. With this, the revision of interpolation and extrapolation is completed. Clear? I hope I am very clear about interpolation and extrapolation. Hope you guys following this. Kindly revise all these things which has been sent earlier, all the videos. Okay. So with this, I am going to wind up the chapter interpolation and extrapolation. I hope you are following this. Okay, so let me start the concept time series in the next video. Okay, I am going to discuss the time series concept in the next video, in the next link. As per the schedule, I think PJ sir has taught the time series concept. I think he might have sent all the links also, but a revision also I'll be doing time series concept. Okay, so time series concept I'll be doing the revision from the next video onwards. Remember guys. So with this, so let me say just end for this interpolation and extrapolation. Let us start in the next video, time series concept. I hope everybody is doing good. Thank you. Have a nice day everybody.